Hey guys, welcome back. So we're going to jump right into the last lesson, lesson 2.6, and I think it's a pretty quick lesson, so it shouldn't be a long video. Okay, so the last lesson of this chapter is going to be looking at what we call flowchart proofs. Now, we don't typically use flowchart proofs. We like to use our T-chart proofs that we were doing in the last lesson, but I do want you to have exposure to this, okay? So it says matching reasons in a flowchart proof. Work with a partner, match each reason with the correct step in the flowchart. Okay, so just like our other proofs, you have the given, and you're asked to prove something. And then you can see the statements are more in a flowchart instead of in our typical T-chart form, okay? So let me get my pen up. There we go. All right, so you're given the reasons down here. We just have to match them. Okay, so you have segment addition postulate, transitive property of equality, given, and subtraction property. So let's start looking for the given. The given is that AC is equal to AB plus AB, right? That's what was here. And that's this first statement here. So that's B, that's the given. Nope, B, given. All right. Then you can see the arrow is pointing here, and it's also from here. So we're going to go down and then over. This piece of information comes from the combined, okay? So down here, it says that AB, I'm probably looking at my diagram for this, AB plus BC equals AC. Okay, well, we already used a given. So my other options are segment addition postulate. I'm going to rewrite that. This is B, given. All right, so we have a segment addition postulate, transitive or subtraction. Well, it's segment addition. Look at it again. AB plus BC equals the whole thing. So this is a segment addition postulate, abbreviating when I can. Okay. Then from there, those two give us this one. So if you look again, I always say look for what they have in common. Okay, what do they have in common? AC, AC. So replace the AC with what it's equal to, or kind of think of it as crossing it out and what's left over, and that's a transitive property. Okay, so the transitive property is C. This is transitive. And then finally, since they both have an AB on both sides, you can subtract it away and you're left with AB equals BC. So this would be D subtraction. All right. So that is the idea of a flow chart. Let's look down, see what else there is in our notes for today. Another flow chart where we're just picking the correct option. All right, so you start with the given. Angle 1 is equal to angle 3, which is here. So that is your given. All right, so E, I'm just going to write the letters this time. E, given. Then you go down, and then those two go over, go down. Okay, so that's how it kind of works. All right, so we have the measurement of angle EBA. So look at the diagram. EBA, that angle there, is made up of angle 2 and 3. That would be angle addition postulate. That's A. Then those two will give us this piece of information. So go and study, what do these have in common? How did this change? So this is stayed the same, EBA, EBA, angle 2, but this changed from an angle 3 to an angle 1, and that's because angle 3 and angle 1 are equal. So I'm replacing this angle 3 with what it's equal to, right? I'm replacing it with the angle 1. So that would be substitution, that's C. Okay. All right, then from there, all that changed, if you look from this equation to this one, they just flip-flop the 1 and the 2, the 1 and the 2, right? They didn't really do much of anything else. So that would be F, that's a commutative property. All right, then from there, we're going to come down here. Angle 1 plus angle 2 equals CBD. Angle 1 plus angle 2 equals CBD. That's another angle addition postulate. So I had angle addition postulate twice. Once as A and once as D. So this could have been D and that could have been A. It wouldn't make a difference. And then finally, look for these two flow together to give you this last one, right? You see the arrow coming from there and the arrow coming from this one. So look for what they have in common. I see a 1 and a 2. I see a 1 and a 2. So I can replace this 1 and 2 with what it's equal with, or I can replace this 1 and 2 with what it's equal with, and it's leaving me with this final equation, and that's transitive, or I would take substitution as well. Okay. So again, that is a flow chart. We don't really do many flow charts, but it's good to have exposure to them. All right. So this is some important postulates that we're going to kind of go through quickly. So the first one is the right angles congruency theorem, which just says all right angles are congruent, which makes sense because every right angle is 90 degrees. So if all right angles are 90 degrees, then they're all equal in measure. They're congruent. Next, we have congruent sup theorem. And this does pop up in some proofs that we're going to go through. And if you remember it, it makes some proofs a lot easier to work through. Okay, it says if two angles are, this should say, oh, it is supplementary. Sorry, I thought it was a complementary theorem. If two angles are supplementary to the same angle or two congruent angles, then they are congruent. What that means is if angle 1, oh, actually it shows the example down here. If angle 1 and angle 2 are supplementary, right? And I'll just make up angle degrees. Let's say that this angle here is, I don't know, we'll say it's 140 degrees, right? I'm just making up angles to illustrate a point. And angle 1 we'll say is 40. Now, would you agree that they're supplementary? Correct, right? So if angle 1 and angle 2 are supplementary, and angle 3 and angle 2. So if these two are supplementary as well, if this is 140, this would have to be 40. All right, so look at this. If those two are supplementary and those two are supplementary, since 1 and 3 are supplementary to the same angle, then mathematically 1 and 3 have to be the same measure. Okay, think about that again. If 1 and 2 add up to 180 and 2 and 3 add up to 180. That means that 1 and 3 have to be the same measure. Then angle 1 is congruent to angle 3. That is what the congruent sup theorem says. And then there's a similar theorem. It's called the congruent comp theorem. Move down. If two angles are complementary to the same or two congruent angles, then they are congruent. All right. If angle 4 and angle 5 are complementary. So again, I'll just make up angle measures. Let's make this one 40 degrees and this one 50 degrees, right? They add up to 90. And then if angle 6 and angle 5 are also complementary, so angle 6 would have to be 40 degrees. Then if those two add up to 90 and these two add up to 90, then angle 4 has to be congruent to angle 6. Okay, so if two angles, meaning 4 and 6, are complementary to the same angle, then those two angles have to be congruent. I know it's kind of wordy, but if you think about it, it actually does make logical sense. All right, next we have, get my pen back. Okay. Next, we have the linear pair postulate. This one is big as well. We use this a lot, so pay attention. If two angles form a linear pair, then they are supplementary. All right. Angle 1 and angle 2 form a linear pair. Oh, my thing's going crazy. I don't know why. Angle 1 and angle 2 form a linear pair. Okay, a linear pair, remember, are adjacent angles next to each other that are also supplementary. So angle 1 and angle 2 form a linear pair, so they are supplementary, which means that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. All right. And we then have, went a little bit too far. Use my mouse. Vertical angle theorem. This is a big one as well. This one pops up in a lot of proofs. Vertical angles are congruent. So remember we talked about vertical angles, opposite V's. So angle 1 and angle 3 are opposite V's. They're congruent. Angle 4 and angle 2 are congruent because they are opposite V's. So angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. All right. Let me look ahead. All right, guys, that is it. We're not going to do the extra practice proof. I think that is enough. So let me get my mouse and come back here. Stop presenting. So that is it for lesson 2.6. And that is it for chapter 2. Nice job. I'll see you guys here for the next lesson. Bye.